Hello friends, so this is Vibha Parekh and I very welcome you all to this channel which is completely dedicated for the chemistry learning and teaching process. So if you are someone who is looking for chemistry classes, you are someone who find difficulty with the chemistry concepts and maybe sometimes with the numerical questions and organic chemistry, I guess. So I think this is one of the platform on YouTube that you can trust with. I will be there to help you throughout your journey of chemistry learning and I make sure that you are well aware of the basic concepts of chemistry. You understand the chemistry instead of cramming this and many of the tricks and tips which are being given on the YouTube. I really don't believe that one should go with those tips and tricks. It's fine if you remember them just for your ease, but this should not be a habit. At least you should learn what things are there inside it, and then you can, of course, just to ease your process, or maybe just to save your time. Those things are also valuable. So today I have brought you some of the thermochemistry based questions because I have seen many times students are very afraid of this concept of thermodynamics, especially when it comes to thermochemistry, which is the one of the most important sections of thermodynamic. And definitely you are going to get some questions, whether you are from the CBSE board or you are from some IGCSE board or GCSE board, from IB board, you are preparing for NEET or you are preparing for IIT, or even if you are preparing for some graduation or post-graduation classes. This is a topic which is very basic and one should be aware of the concepts which are there in thermochemistry. So today I have brought you some of the questions and let's try to solve them and try to understand this part of thermochemistry even better if you already know this, and to some extent if you are new, come, or if you're a class 11 student. Okay, so let's begin with some of the questions. I will try my best so that I can provide you the variety of questions here. And otherwise, if you still find any difficulty after this class, then of course you can tell me if you have any questions in your mind. Of course, the comment section is just for you. So please mark the question. Please tell me the questions you find difficulty with, and those questions where you found that the explanation was not enough. Okay, let's try to see the questions now. See, let's say the question number 1 is about the enthalpy of reaction. Okay, see here. What is the value of enthalpy of formation of methane? Okay, from the given enthalpies of combustion. See, always understand when we are talking of the enthalpy, so what is your enthalpy? Enthalpy means delta H. We are most of the time we are interested in finding out the delta H of reaction, the enthalpy of reaction. Now, what is this enthalpy of reaction? Enthalpy of reaction is nothing but the heat which is supplied at constant pressure. See, most of the time the reactions that we are doing in our chemistry lab, they are being done under the atmospheric pressure, under the constant pressure. So whatever heat that has been supplied or that your system is taking out, that is nothing but the enthalpy of reaction. Okay. Now, enthalpy of reaction could be found based on different informations for a certain reaction which are given to us. For an example, in this question, you can see I'm talking about question number 1. They are asking you to find out the value of formation of methane from the given enthalpies of combustion. So these are some of the combustion enthalpies given to you. When carbon is being burned in presence of excess of oxygen to form carbon dioxide, this much is the energy which is released. Enthalpy of combustion, they are always exothermic process, so that's why delta H will always be negative. Okay. Here I'm taking the concepts a little fast because I assume that many of you are already aware of these concepts. But if you are someone who does not know the concept, please tell me. I will make a video just which is based on the conceptual part of this chemistry. Okay, here we are just doing the questions. Now for water as well, they have given you the enthalpy of combustion, and for here you can see for methane as well, they have given you, not water, sorry, hydrogen, they have given you the enthalpy of combustion, carbon, they have given you the enthalpy of combustion, and for CH4, they have given you the enthalpy of combustion. So all of them are exothermic, as you can clearly see. But we want to form methane. Whenever it comes the formation of methane, there are two things that you should always understand. The thing that you are trying to form should always be 1 mole of that product. Secondly, the thing which you are being forming, like in this case of methane, so all the constituent things that are being forming of the methane, they should be in their elemental state. Okay, here I'm talking about your reactants, they should be in their elemental state. What is elemental state? Elemental state is the state of a substance in which it is found in its most stable form at room temperature. Got it? For an example, here I want to form CH4, methane. So I should be forming 1 mole of methane. And in order to form methane, see what are the constituent elements here? Carbon and hydrogen. Carbon in its normal general state at room temperature, it exists in the solid form in the form of graphite. Okay, graphite is the most stable state of carbon. Plus, when it comes to hydrogen, we all know that hydrogen exists as a diatomic hydrogen molecule, which is gaseous in state. And CH4 methane is also a gas. Do you understand? So this should be 1 molar of the compound. So we can see the methane is being formed to 1 molar. And after that, you can actually balance your equation accordingly. Like here, you can see that you have to form just 1 mole of it. So carbon number is satisfied, although the hydrogen number is not satisfied. So just make your equation balanced in such a way that you should only be getting the 1 molar of CH4 here. Okay, so this is your enthalpy of formation, and they are asking you what is this enthalpy of formation for methane here. Is that understood? Now for carbon, they have given you the combustion value, which is equal to minus of 394 kilojoule per mole. For hydrogen as well, they have given you minus of 286, but this time we have 2 moles of it. So let's multiply this with 2. And for methane as well, they have given you the combustion values. So what do? Whenever you have to find out the delta H of reaction and the combustion values are given to you, always remember that you will do delta H of combustion of, just remember this thing, this is very important, reactants minus the enthalpy of combustion of the products. Got it? It's reactants minus product this time. But why is this so? Why it's not product minus reactant? So in my conceptual part or the things, the questions that I've already uploaded based on thermochemistry, I have given you the full explanation of this part there. But here you can just remember it's reactant minus product. Now, what are my reactants? So you can clearly say it's minus 394 minus 2 times of minus 286. Okay, not minus, it's plus, right? So these are my reactants. I have summed them out. And what is the combustion value for my product? So that's equal to minus of 891. So this will be minus 891. Now just solve your question and you will be able to get your answer. Although the options that are being given to us, you can clearly see that they are not being solved. So just match your answer over there. So let's try to see what should not be the answer or what should exactly be the answer here. See, of course, this is not the answer because they have nowhere involved the 2 moles of hydrogen. So this is not the answer. This is also not the answer for the same reason. So we should be confused between B and D. But you can clearly see the one that is matching with my answer is minus 394 minus 891. No, it's not minus 891. It's actually minus and minus. So this becomes plus. So it's plus 891. So that makes D to be my answer. Got it? Similarly, let's move on to the next question. What is the enthalpy change for the following reaction? So here you are being given this reaction. You might be able to see this is a hydrobromination. Okay, because here my halogen is bromine. That's why I'm calling this as a hydrobromination reaction. Otherwise, if it is some general halogen, you may call this as a hydrohalogenation reaction. Got it? So this is this kind of reaction. We have butane and we are doing its hydrobromination so that I'm being able to get bromine here and a hydrogen being attached here. Okay, that's the simple reaction that I can see. CH3CH double bond CH2 like this, no? CH. So we have a CH here and we have CH2 here. Got it? Now see, when it comes to CH3, CH, CH2, CH3, so what I may see, I'm so sorry, it's not this thing, it's actually this one because we have CH2 here and CH here. No? So that means I need to put my bromine here and hydrogen here. Just correct this thing. So my hydrogen will come here and bromine will come here. Got it? So that's the thing that we have made. So this is a hydrohalogenation or hydrobromination reaction. Now for this reaction, they are asking you what is the enthalpy change. Okay, that means again, they are asking the delta H of reaction. What information they have given you? They have given you the delta H formation of all these compounds individually. So delta HF of this butene is equal to 0.1 kilojoule per mole. For HBr, it's minus 36.3. And for this one, the final compound, it's equal to minus 56.0. Now what you need to do, again, you take delta H of reaction. This time, the summation of the delta H formation of products minus reactant. This is something very important and different from that of combustion. You should remember it's products minus reactant when it comes to the enthalpy of formation. Because actually, if you see that the reaction of combustion and the formation, they are entirely opposite to each other. That's why this makes the whole difference. Okay, so for formation, just remember this thing, it's FPR. This is how you can remember it. FPR means formation. In the case of formation, if you want to find out the delta H of reaction, this will be product minus reactant. But for combustion, this is reactant minus product. Okay, although product minus reactant is most general thing and is being followed by most of the reactions. Now, I think rest of the part is very simple. So the enthalpy of formation of your product, what is that? My product's value is minus 156 minus the enthalpy of formation of all the reactant, which is 0.1 here and minus 36.3. And since I can see that this reaction is already balanced, so I need not to multiply or divide with anything to make it the same as that of the number of moles. Now you just solve this thing, you should be able to get your answer. And I'm very sure you will be able to get your answer as C, which is minus 119.8. Got it? So this says that your reaction is what? It's the exothermic in nature. If it is negative, that means it's an exothermic reaction. Okay, nice. So now coming on to the next reaction, which combination of delta H1, delta H2, and delta H3 would give the enthalpy of reaction? Again, this kind of question, this is very important, right? So we are being given this reaction CS2 plus 3O2, and this gives you CO2 plus 2 moles of SO2 gas, okay? Their physical states are also important, but here I'm not writing it down because it's understood all the other states will be in the same manner. But you should always consider this part as well. So now they're asking you what combination of delta H1, delta H2, and delta H3 may give you the enthalpy of reaction for this one. So let's write this as the reaction. This is some reaction. We do not know what is its delta H value. This is what we need to find out. Now just try to assume, like just try to identify what is this information given to us. In all of them, you can see that it's carbon in its elemental state, oxygen in its elemental state, and forming the carbon dioxide. Got it? So that means this is the enthalpy of formation of carbon dioxide. This one is the enthalpy of formation of sulfur dioxide. And this one is the enthalpy of formation of carbon disulfide. So all these informations are actually the information of enthalpy of formation. This is clear? Okay, now you may ask me one question that why they have given you the formation values for CO2, SO2, and CS2 and not for oxygen. See, your oxygen is already in the elemental state. If it's already in the elemental state, what does that mean? It means that in the nature, it's existing as an oxygen molecule. You need not to form it. You need not to put any effort. You need not to put any energy. So even you want to find out its enthalpy of formation, which is delta HF, which is H enthalpy final minus enthalpy initial, you are not forming it. It's just been there. So even if they have some energies, which is definitely been there into the oxygen, but they are same initially and afterwards. So that's why this value will be equal to 0. Got it? Now let's write down all those values. For CS2, you can see this value is equal to delta H3. This is enthalpy of formation one more time. This is enthalpy of formation values. For oxygen, this will be 0. For carbon dioxide, this is delta H1. And for sulfur dioxide, you can see it's delta H2. But since we have 2 moles, so put it 2 times of this. And for better thing, you can also put it as 3 times 0, although this is going to be 0. Got it? Now I need to find out the delta H reaction. See, what did I tell you earlier in question number 1? If the enthalpy of formation values are given to you, what would you do? Enthalpy of formation of products minus enthalpy of formation of reactants. I hope you remember this thing. It's product minus reactant in the case of formation. So now just put down the values. So my products are delta H1 plus 2 delta H2. Okay, so this becomes my products part minus delta H3 plus 0 like this. 0 does not make any sense. So just make the final answer as delta 2 delta H2 minus of delta H3. I hope this part is clear. Now you can match your answer. I can already see this answer is D. So let's match our answer with the D part. Delta H1, 2 delta H2 minus delta H3. That is also our answer, right? So I guess now you have been able to get the idea how we need to proceed with these kinds of questions, which are related to the energy aspects. Now, when the sodium carbonate powder is added to ethanoic acid, okay, it's sodium carbonate. So let's write down the equation. Let's try to write it down. Even if you don't know much chemistry, you should always try to write the reactants and try to find what could be the possible product. So here, this is CH3COOH. That's the ethanoic acid. The beaker becomes cooler. Okay, cooler means this will be a endothermic or exothermic reaction. Definitely, this will be an endothermic reaction. That means its delta H value will be positive. Got it? Now, when this reaction happens, what would you see? Na2CO3, which is your sodium carbonate, reacts with the CH3COH, which is an acid. This will form CH3COONA, okay, which is the acetate, sodium acetate. Also, this forms carbon dioxide because we have a carbonate here, and along with this, you may also see water to be formed. Got it? So that would be the reaction. But what we can also see is that this reaction is endothermic in nature. What does that mean? It means that the total energy that we see, there is one concept I just want to tell you because sometimes I've seen the people are very confused with this endo and exo concept. They just remember it, they cram it, but they don't understand it properly that why delta H value is positive here. See, there is a law of conservation of energy which says that the energy left hand side and right hand side, this is always going to be the same. That means if in a beaker you have put some reactant, so the energy that they are holding in the whole beaker, in the whole system, at the end of reaction, that should also be same. But how is that possible? Earlier, they were the reactant, they were different species. Now, when the reaction is done, they are a different species. So different species hold different internal energies. So how the energy could be conserved? See, the total energy I'm talking of. Let's say that the total energy this side is 10. So this should also be 10 this side. Okay, let's try to make this example even simpler. Let's say that I'm saying, what I mean to say is that you have a reaction A to B. Okay, A is my reactant. So what I'm saying is that the energy content, total energy content should be 10 here, and this should also be 10 here. But let's say that this reaction is endothermic in nature. What does that mean? That I'm supplying some energy so that this is energy. Okay, don't get confused with the electron. This is energy that I'm supplying on this side. Still, the total energy should be equal to 10. So it means that actually, let's say I'm supplying 2 kilojoule per mole of energy. Then the energy of your A was actually 8. And here, the total energy that your thing is holding, because it's not releasing any kind of energy, right? So your B has this energy of 10. Earlier, the energy of A is 8. And the energy that you're supplying is 2. That makes it 10. So see, the energy is conserved, although the energies of your A and B constituent things, components, they are definitely different. Okay. Now, when you find out the delta H, what would you do? Products minus reactants energy. Products energy, as we can see, it's 10, and the reactants energy is what? That's 8. So now you can see it's 2. What is this? It's a positive value. That's why we say that it's an endothermic reaction. So when the energy is supplied to the reactant portion, then your delta H value is always going to be positive. And similarly, now you can write it down for the exothermic reactions, where the energy will be released on the product side, and ultimately you are going to get the delta H value to be negative. Just try this out. I'm giving you this as the homework. Okay, so please try doing this part on your own. Just try this. This will be a fun activity. Got it? So here we are supplying some energy to it. That's why the other part, which is consuming the energy, is becoming cooler this way. Got it? So definitely it's an endothermic reaction, but which one? Like we have C and D option. This, no, C and A option. So this is either endothermic. So definitely B and D are not the parts. Now, whether 1 or 2, which diagram shows the process to be endothermic? See, we already discussed the energy of my reactant is lesser than the energy of the product if it is an endothermic reaction, which clearly says the diagram is this. The reactant's energy, let's say the reactant's energy is 8 and the product's energy is 10. So clearly the product's energy is what? That's higher. And 2 moles of energy is being consumed by the reactant so that it can form the product. Okay, and what is this extra energy? See, this no, not this one. I'm so sorry. This extra energy that you can see that reactant have to take so that it can get converted to product, this is what you call as the activation energy. So what is delta H, ma'am? Where is delta H? Can you show that delta H in this diagram? Definitely. This difference in energy between the product and reactant, that's your delta H. Got it? And which is here in this case is equal to +2. Is that clear? So definitely I can say my answer is second diagram and endothermic process. That means the answer C. Got it? Okay, nice. Now let's move on to the very last question for today's session. We have many more questions, but I don't want to make this video a really long. So let's just do this question, which is the question number 5, and let's end this session here itself. Okay, what is the enthalpy change for the reaction? Again, they are asking you delta H of the reaction when the reaction given to is 2 carbon, which is in the graphite form, plus oxygen and carbon monoxide. So you can see it's actually the combustion of your carbon, right? And forming carbon monoxide. What kind of combustion? This is actually incomplete combustion. Incomplete combustion, which does not release carbon dioxide and releases carbon monoxide. This is not something a good thing, because this will produce a lots of smoke without producing good amount of energy. Ultimately, from a fuel, we want energy, not the smoke, right? But in this case, if carbon monoxide is formed, it's actually a incomplete combustion and will result into more amount of smoke and less amount of energy. So this is not something that is desirable. But if someone asks you what reaction is this, so this is a combustion reaction. Got it? Okay, so that's your reaction. Let me just write down the reaction first. 2 carbon, 2 moles of carbon, which is in the form of graphite, plus 1 mole of oxygen is releasing 2 moles of carbon monoxide, again, which is in the form of gas. This is also in the form of gas. For them, they have given you delta H, not combustion values for graphite. So for graphite, the delta H combustion value, okay, it has standard condition. So this has been given as minus 394. And for carbon monoxide, it's been given as 2 minus 283. Since we have 2 moles, so multiply this with 2 and also multiply this with 2. So you always remember the delta H naught combustion values are always given per mole. Whatever is its value, if it is a standard enthalpy combustion value, this will always be in per moles. So this is just for 1 mole. Since we have 2 moles of carbon and carbon monoxide, we need to multiply them with 2. Got it? Now they are asking you the enthalpy change of reaction. Oh my God, this is going to be so simple reaction, right? Equation, because this is exactly the second question that we discussed. So since it's combustion, what will you do? Just write it down in the comment, or you need not to write it down in your comment. Please write it down in your notebook and try to give the answer faster than me. So this will be summation of delta H of, this is combustion, no? So combustion of reactant minus the summation of delta H combustion of the product. Got it? So now my reactant, what is my reactant? So my reactant is 2 moles of minus 394. Why we are not including oxygen for the combustion? See, oxygen acts like a fuel, which actually causes the combustion of reaction of a certain substance. Here it is oxygen itself. If you are trying to burn the oxygen and presence of oxygen, that does not make any sense, because oxygen and oxygen, both of them are the gases. They will just combine together and will give you higher quantity of oxygen, not the burning of oxygen. You cannot burn something with its own, right? That makes sense. So that does not make any sense. So that's why we are not including this. Now coming on to the carbon monoxide, we have 2 moles of it and the combustion value per mole is 2 minus 283. Now to solve this thing, you will be able to get your answer. Although you need not to do this part as well. You can clearly see what should be our answer. So 2 times of my reactant minus 394. And here you can further solve this to make it minus 394, and this will become minus will become plus, and this becomes 2 times of 283. So you can clearly see your answer is resembling to this option number D. Okay. So I guess this was something related to that of combustion reactions and the heat of formation values, if they are being given to you. So how would you apply those values? How would you put them based on product minus reactant or reactant minus product? This is what you need to be clear of at this stage. But still, see, here I have given you this whole questions based on the idea that you already have certain information in your mind with respect to thermochemistry. But if you are someone who is a beginner for thermochemistry, you do not know anything about it, or is there if there any other topic that you find difficulty with, which is related to thermodynamics, for sure, so that you can tell me, so that when I give you another 5 questions in my next class, so I can give you a more detail about that particular thing, like whether it's delta H or whether it's delta G, or you want to know about the heat, or you want to know more about the calorimetry, just giving you a certain idea. Okay, so I hope that this was a useful session for you. And again, if you're someone who is looking for good chemistry classes, that too for free, and you have certain doubts in your mind, you have studied all the things, but still you find it very difficult. You do not know how to apply the things, how to understand them, how to put it down on the paper, how to get the answers. So please, I would say that please subscribe the channel and then try to commute your problems with me, and I will try to solve it as soon as for you, and will make dedicated videos which are just for the chemistry learning, and for me this will be a fun teaching experience. So thank you so much. I will see you in my another class with next 5 videos based on thermochemistry. Till then, take care.